So we've talked about rigid transformations, and that's where you have transformations like reflections, rotations, translations that don't change the size or shape of the figure. They just move them around on the plane. And so we're going to take a look at transformations and how they relate to similarity. Okay, so in these two triangles that we have below, we have triangle ABC and triangle DEF, and we are told that the measure of angle A is equal to the measure of angle D, so those two angles are congruent. And we know that the measure of angle B is equal to the measure of angle E, so again, we know that those two are congruent. And we need to use a sequence of translations, rotations, reflections, and or dilations, which is the only non-rigid transformation, to show that triangle ABC is similar to triangle DEF. Okay, and so the first thing we're going to do is we are going to translate our triangle ABC so that way vertex A or point A lies directly on top of D. Okay, so A prime is the same point as D. And then we can see the vectors here in red. These are your vectors. And the vectors for each of these translations, for when you're translating each of the points, the vectors are the same. So the length of that vector is the same, and the direction of the vector is the same, which means that all three of those vectors are parallel to each other. Okay, and so we've just taken that figure, that triangle, and we've translated it over. Okay, so we've basically mapped A onto D. All right, then the next transformation that we're going to do is we need to rotate. So we're going to rotate that triangle that we have translated. We're going to rotate that a little bit counterclockwise, so that way segment A prime C prime will lie on top of segment DF. Okay, and so then you can see that this blue figure, the blue triangle that happened, that was created when we translated it, has now been rotated counterclockwise about this point D, or A prime, or A double prime now. Okay, and so now we can see that the angles line up. So now it's just a matter of dilating the figure. And if we dilate about this center, so remember it was the center of rotation, it's also going to be the center of dilation. So we can dilate it with a scale factor of, let's say, FD to C prime, or I'm sorry, double prime, A double prime. Okay. And so when we dilate that by that factor, then each of these line segments in the original triangle, or the A double prime, B double prime, C double prime, they are going to grow by this scale factor. And when we do that, C will then line up with F, and I'm sorry, C double prime. B double prime will then line up on E, and so we can use that to show that those two triangles would then lie on top of each other. And so then that means that those angles do match up. All three of the angles do match up. So we can say that if we know two angles of two triangles are similar, then we can say that the two triangles themselves are similar. Okay, so if two angles of one triangle are congruent to two angles of another triangle, then the two angles, I'm sorry, the two triangles are going to be similar. So just like we could use angle, angle, side, angle, side, angle, side, angle, side, 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 to show that two triangles are congruent, we can use angle, angle to say that two triangles are similar, okay? Not congruent, but similar.